So we can get started on this presentation of conquering regional air transportation with a reduced noise footprint. I am Tim Middleton. I am a principal consultant with HMMH, and I have about 17 years of experience in the aviation industry, starting my career at Teterboro Airport in the noise office, and now supporting clients around the country addressing noise issues. And over the last few years at this conference and others, there have been discussions about advanced air mobility, electric aircraft, and electrification of aircraft, and how these new entrants will be accepted or integrated into the existing fleet. And so we've put together a panel to try to give an update to all the attendees on where the developments of AAM and electrification infrastructure are. And so what I'm going to do is I'm going to introduce our panelists, because we have 3 and 2 are going to be virtual. And the way we put this panel together is to first we're going to have NASA speak to give an update on where they are in terms of the research on the noise. And then Lacy Aviation, so Scott Cutshall from Lacy is going to speak about how the fixed base operators and the operators of airports are looking to prepare for electrification. And then we have from Caltrans is going to speak. So we have some synergy between the University of California and Caltrans in terms of how Caltrans is preparing for these new aircraft. So because we have 2 virtual attendees, I'm going to read all 3 bios for everyone, and then we're going to roll into the presentations. So Aaron Vaughn is from NASA, and Aaron Vaughn got sick, and so we have a little bit of a next person up, and so Andy Christian's going to present for Aaron. So first, Aaron Vaughn is a research aerospace engineer in the Structural Acoustics Branch at NASA Langley Research Center in Hampton, Virginia. In one capacity at NASA, Aaron conducts psychoacoustics research to characterize human response to urban air mobility vehicles in support of NASA's Advanced Air Mobility mission. Aaron also participates in community test and planning execution for the commercial supersonic technology project under NASA's Quest mission with the quiet supersonic X-59 aircraft. Aaron holds a master's degree in physics from Brigham Young University, where he also studied Japanese and conducted research on jet noise. Andy Christian I'm going to introduce, who will be providing the presentation today. Andrew Christian is a researcher in aircraft psychoacoustics at the Structural Acoustics Branch of NASA Langley Research Center, and he has a BS in Applied Mathematics from NJIT and subsequent experience as an audio engineer, which prepared him to get his MS in acoustics from Penn State. And he's been working at NASA for the better part of a decade, where he conducts research on human response to the noise of airplanes, helicopters, drones, and other concepts. His writings typically include pontification on psychoacoustics, signal processing, and statistics. So Andy, if you could please begin your presentation from NASA, and we appreciate it. And Jonathan has also joined us. Jonathan Rathsam from NASA works with both Andy and Aaron, so thank you. Go ahead, Andy.
Thank you for that introduction. It's unfortunate that Aaron got sick, but he put together a really beautiful slide package. My hand in this was, I had attended this conference a couple of years ago, and when it was in Davis, and so I had just helped him kind of prepare for what he was in for. This is not, a technical conference, which is what we're used to speaking at. And it seems like I did a pretty decent job of intuiting what the tenor of this conference was going to be. So I will, having just watched the keynote, I think that this is going to actually kind of dovetail pretty well with what's going on. So, So in terms of urban air mobility, I suppose I'm the first person to kind of introduce this. So this is kind of like both a rural and urban application of future electric aircraft. So these are electric or hybrid electric vertical takeoff and landing aircraft. You can see in this nice photo, maybe they land on the top of buildings, or they land out in the middle of a river, and they can take you, from an urban center to an airport, or they can take you, regional air mobility is a good word. There are a lot of acronyms that get thrown out: AAM, UAM, which is more like people drones, air taxis, UAS, which is more like package delivery kind of stuff. And these are kind of all, they can do any kind of missions, obviously, but these are kind of all thrown in the same basket. And so where I fit into this picture and where Aaron fits in is characterizing the human response to the noise of these vehicles. So the first thing I want to talk about is just kind of give a little context of how NASA fits into all this kind of stuff and what are some of the things that we do. So I work all the way on the left of this figure doing the laboratory psychoacoustic testing, but we also do a little bit of community noise testing. We produce kind of, newfangled human response metrics. And then those are handed out to people in academia, people at FAA, ICAO, and also people who design these kind of future aircraft. So we're not regulators ourselves. We're not building any vehicles ourselves. We just develop and kind of update noise response predictions, models, things like that, that are factored into all these other activities, which are government, private industry, things like that. And just some kind of like quick history. We've been in the game for a long time, from the 1950s and the dawn of the jet age. The building I'm in right now is the one that's pictured, constructed in the 1970s, the Aircraft Noise Research Lab. And we've done a lot of things over the years, wind turbine noise, fixed wing noise, the noise inside of airplanes, helicopters, things like that. Over the years, other research centers within NASA, like AIMS, have had their own audio labs come online. Another thing that we do is what we call oralization, where we can now pretty confidently fabricate the sound of planes that don't yet exist. So we can fabricate these sounds and then do a psychoacoustic test where we ask people, what they think about the sound of a plane that doesn't yet exist. So, and this has gotten into remote testing with COVID and everything, just doing everything online. So these are some of the activities that we've done throughout the years. The two main facilities that we have in this building right now are the exterior effects room on the left, which is supposed to be kind of like an outdoor environment where there are speakers all around you. And so we can take, for instance, the sound of a UAV and fly it over your head in different ways. And, or, maybe it's a sound of a car and it passes in front of you, things like that. And the interior effects room, which is actually what Jonathan has been more involved with, which is about commercial supersonics. Aaron also is more involved with that than I am. But these are our two main test facilities. So I kind of want to change gears and talk about the noise and number problem a little bit. So recently, one of the things that we've really been interested in is noise and number problem. So this is trying to figure out how people integrate between different events, right? And so you can imagine this kind of a figure here where you have the sound of a highway and then you have the sound of these, UAVs or whatever that are actually going from, building to building or whatever they're doing. The sound of the highway is kind of a constant thing, right? It's a kind of a shh. It just, you can't really hear individual sounds, whereas the sound of an airport is something that's either kind of a rare event that happens, you have a very, not very busy airport, it happens once a day or something, twice a day, or you have a kind of frequent noise event where it's happening like once every other minute or something like that. And so what we're looking into is trying to figure out how people really add sounds between events in these different regimes. And I want to try and like incept something into the minds of everybody. And we're talking a lot, obviously at this conference and recently, about these different noise metrics. And I want to try and get across the idea that a lot of these can actually be conceptualized as lying on a line. They're not individual different hypotheses. And so when you talk about a max event like DBA max, that's one edge of this line, let's say this is, this left-hand side of the line. Then on the right-hand side of the line, you have something where you have a number of events. People are responding to the number of things. And they don't actually care about how loud each one of those things are. They're just responding to the number of them. There are a lot of them. That's what I'm responding to. These things kind of oppose each other. If I'm responding to the loudest thing, and that's actually what I'm doing, I could have a million things that are quieter underneath there, and I could pack those all in, and they won't affect what the loudest thing is. On the other hand, again, with the number of events, if you're actually just counting the number, you don't actually care about how loud each one individually is. If you draw a line between these two, there is a kind of natural trade-off, this kind of equal energy hypothesis, which is baked into the day-night level. It's baked into a lot of things, the sound exposure level, EPNL. It's baked into a lot of metrics that we use. And these kind of things all fall on a line. So you can actually be in between equal energy and number of events, just like you can be in between equal energy and the loudest event in terms of the reaction of a person or a group of people. And so I'm going to throw up this, this much reviled figure here on the right now, where we see that equal energy, the trade-off that kind of dictates is this thing which I think a lot of people find to be kind of confusing. Maybe not the first step between, going from 1 plane to 10 planes is an addition of 10 dB, but then somehow going from 10 planes to 100 planes is only the addition of another 10 dB. It's this multiplicative factor. And so if you go around different points on this line on the left, you will get different responses. You'll get different versions of this figure. So that, for instance, if we codify this with a number K, we say K equals 10, that's equal energy. As we go towards the number of events, let's say K equals 15. So now we're turning this number up. So now as we go up 10 dB, we're going to 5 planes, the factor of 5. So then we go up another 10 dB and we get to 25. Now we've got 20 dB going from 1 plane to 25 planes. On the other end of the spectrum, as we go down towards the loudest event and K equals 5, now if I go from up 10 dB from 1 plane, I go to 100 planes right off the bat. By the time I get to K equals 0, I can go to infinite planes, right? I'm only responding to the loudest thing. It doesn't actually matter. So this kind of scale, again, dovetails with this figure that everybody is familiar with. And you can look at it graphically here as a figure, NASA, so we got to throw up a figure with a logarithmic x-axis here. So the number of events is kind of like the top of the figure, and the loudest event is kind of like the bottom of the figure. And you can take this line and sweep it up and down by changing this K value. So one thing I want to kind of like back up and say, and this, again, it gets into what was just said in the keynote. It's not just that there were a bunch of different things done in the 70s in the US. If you looked around the world in the 1970s, people actually, a lot of different countries had their own standards and their own metrics, and many of them used different Ks. And the list is actually pretty extensive when you go back and look into it. So, Austria had a different K than Germany, had a different K than South Africa, had a different K than the UK, had a different K than, Liechtenstein probably. And so there were people who used K equals 10, whether it was DNL. Also, I should say that the noise exposure forecast, the NEF, which is used by Canada, Australia, some other place, that actually uses K equals 10. So it's not different in this respect. The world right now almost completely uses K equals 10. The UK was the last one standing. They used K equals 15 for a while. But all these other countries used K equals 13.3, 12.5, 20 back in the 1970s. And over time, that all kind of evolved down to everybody using DNL and K equals 10 being a thing. So So now we've got this parameter, K, and we've got this line for scientists. So what we're going to try and do is formulate a psychoacoustic test where we can try and figure out what people are doing. So what should K be? Should it be 10? Should it be 15? Should it be 20? Should it be something else? And so we did this about a year ago. We did the noise and number test in the exterior effects room. Subjects were invited to come in. We had about 40 subjects. They would read for 4 minutes at a time. They would bring their own reading, or we give them something, completely enthralling, like journal articles and stuff, to sit there and read. And then they would be played in this kind of environment where we can make things sound pretty realistic, a certain number of events over the course of 4 minutes. So you can see here on the left, these are kind of like sound level meter histories of 2 things flying overhead in the course of 4 minutes. And then there was another condition where they did 8 things flying over their head over the course of 10 minutes. And we were manipulating the level of each event relative to the number of events. And we even had a case that they did where there were 1,000 things flying over their heads, which is interesting for another reason. But after a 4-minute period, they were asked to rate their annoyance on this kind of standardized 10-point scale on the right-hand side. And so what we were interested in, we were doing this with UAM sounds, these kind of like oralizations of UAM. So we don't actually have recordings really of these things. They don't really exist yet, but we were able to fabricate the sounds of what we think they might exist. And we were interested in getting higher than, as you can see, the lowest thing that we did was 1 event every 2 minutes. So this is kind of like in this frequent regime, right? And we were interested to see what the transition would be like as we go into constant sounds. So by the time you get up to like 8 sounds, 16 sounds, 32 sounds in a span of 4 minutes, you get into that kind of road-like sound where you can't really hear out individual events. And so we wanted to know what was going to happen at this interface. This is something that's never really been looked at because community studies, if you're in the natural environment and you're around an airport, for instance, things only go up to about 1 event per minute at most, just because you can't fly conventional fixed-wing aircraft any faster than that. As was mentioned before, with UAV, UAS, in order to make that economically viable, we're going to have to go faster. I'm not going to do anything. I'm going to be rolling my eyes, but somebody's going to have to make this go faster than that. I don't know if we're going to get to 1,000 a minute, but past lab studies have also only looked up to about what was possible at an airport, because why would they go any faster than that? And so this study kind of bridged this weird gap in here. And roughly what we found was that this transition, at least for the sounds that we were using, came in at about 2 events per minute. So once you get beyond 2 events per minute, and these are quite long events, they're not like cars passing by. These are quite long events flying over your head relatively slowly. That's when things kind of blended together into one, thing. Once that happens, people kind of reverted to the K equals 10 DNL trade-off. So then you could make the road bigger, right? And DNL would correctly predict what was happening. One of the interesting things, probably the most interesting thing from this study, is that there was a definite change in the trade-off that people were making below this. So when they were in the lower number of sounds per minute, when they could really hear each individual sound, the trade-off that they were making was much more aggressive in terms of penalizing the increase in the number of events. It was much more like K equals 15. And so this now, again, is getting back into this frequent regime, which is what you would see of like a busy airport. There's a lot of cause to believe that with very rare sounds, you kind of these blue dotted lines, at some point it transitions back down to K equals 10. But this was a very interesting study because we kind of observed for the first time that you could have different trade-offs for different regimes of sound, right? And this can be their kind of thing about like every community is different. Every community is sonified at a different rate, these kind of things. I will also mention briefly that every subject is different. And one of the pieces of work that Aaron has been doing quite recently has been really to dig down and look at each individual subject. And each subject is quite different. This step behavior is kind of like an average over everything. I want to make one last slide here and kind of show how number above interacts with these different concepts. So again, I said, the top of this figure is kind of like the number side of the figure, and the bottom of this figure is kind of the max. So if you look at number above, it's an interesting metric. When the number of events are few or are not changing very much, number of above is this red curve as opposed to all these straight lines on this plot. So number above actually penalizes an increase in number less for a small increase in the number of flights than equal energy. Once you get to a higher and higher number of events, though, it kind of blows up in this way, in this curved way that is not really captured by k equals 15, k equals 20, something like that. And so it's got that going forward and going against it, depending on how you look at it. I will point out that in the 70s, there actually was this thing called the Kosten unit, which I think was used in the Netherlands, which was an implementation of number above. What happened with that is as planes got more frequent, higher in number, they necessarily got quieter. But remember, when you talk about number above, there's this threshold. And so you set the threshold, and then as planes start to get quieter, but more numerous, they start falling under that threshold. And so this Kosten unit that was being used based on number above started going way down, even though annoyance was going up. So there's different ways that number above can really kind of break in ways that these logarithmic based metrics can't or don't tend to, in terms of equal energy or whether it's another trade-off that people are making. So just kind of another piece of interesting history. So I think that's about it. In summary, NASA conducts AAM research, advanced air mobility research, that informs regulators and manufacturers, though we are not a regulator or manufacturer ourselves. And a single metric with a continuous K factor can provide insight into human response to noise and number, but it also can show that there can be different regimes, and it doesn't have to be equal energy. Yeah, thank you. I hope I did this justice.
I think so, Jonathan. Yeah, very, very good. Thank you. Appreciate it.
Thanks.
Thanks for the audible to cover for Aaron. We really appreciate that. So I just want to introduce Alex Gertsen from NBAA, who was instrumental in helping put this panel together. And Alex is going to, oh, go ahead. And so Alex is going to introduce Scott Cutshall, who's going to speak for Clay Lacy. So go ahead, Alex, and then Scott.
Oh, it's working. Okay. Thank you for that wonderful introduction, Tim. Tim did so much work as well, and I want to make sure that we recognize Jonathan as well, who is not with us, who did a lot of work behind the scenes. And when we learned that Aaron was sick, Jonathan very quickly pivoted and was able to get Andy, which was just a great presentation. I think all of you have learned a lot. Please welcome Scott Cutshall. Scott is with a company called Clay Lacy. And when he introduces himself, he'll say, well, you think when I say Clay Lacy that I'm from Van Nuys. And I know we have community members here from Van Nuys. And while they do have their headquarters and a strong presence there, Scott is actually responsible for their location at Orange County John Wayne Airport. And him and I have been working together for close to 5 years now, as that location build out is continuing, as the visioning process for the airport is continuing. Scott has done an incredible job leading that effort, working with both the airport as well as many communities that surround the airport, and taking the perspective of the importance of integrating communities into the process. So I think you'll hear that throughout his presentation. He's a pilot, has been in aviation for a very long time, and we're very fortunate to have him with us. And he'll be talking about some innovative aspects of what they're doing as they modernize the general aviation area at Orange County.
Good morning. My name's Scott Cutshall. I'm with Lacy Aviation. I lead forward-looking strategy for the company, as well as our sustainability initiatives and workforce development. The perspectives I'm going to be sharing with you today come from my experience in speaking with a variety of eVTOL manufacturers and the group that we're working with in constructing our new FBO at John Wayne Airport in Southern California. And through those conversations, we have planned for and are preparing to begin installing charging infrastructure for electric aircraft. Before I get into the next step, just a little bit about Lacy Aviation. We're a 55-year-old privately owned, family-owned company that was founded by an aviation pioneer, Mr. Clay Lacy, who's still very active. We are primarily an aircraft management company managing 160 private aircraft in 37 cities across the United States. About half of those airplanes are available for charter. We do heavy maintenance at our repair stations in Los Angeles and Connecticut, and we have 2 FBOs, Van Nuys Airport and John Wayne Airport in Southern California, and we're opening our 3rd in Waterbury, Oxford, Connecticut, about a 2-hour drive north of New York City this summer. So to frame our conversation, I'm going to be speaking about charging infrastructure and community engagement, and then kind of the movement of how we anticipate these airplanes moving on the ground relating to parking, landing, and passengers coming and going. We've all heard a lot of promise about the future of electric aircraft and urban air mobility and eVTOL and AAM and all these terms, and we've heard grandiose plans in the future of, getting off the roads and avoiding traffic and seamlessly commuting from one place to another. And I think it's important to understand, and for the purpose of my talk today, I'm focusing on what I call the near term, which is the next 10 years. And then I think we can move into midterm, and then I think we can move into long term. But all my comments today are focused on near term, just for context. All right, so sorry, the formatting all moved on me. So let's talk about each of these elements really quickly. I'm going to dive into them, but charging infrastructure, what I mean by that is the power requirements, funding challenges. It costs a lot of money to put this infrastructure in, and fixed versus mobile. The concept of I bring the aircraft to the charging infrastructure versus bringing the charging infrastructure to the aircraft. Very different, and they have a lot of differences. Community engagement. Obviously, we're talking a lot about noise. There's a lot of questions about routes. Where will they be flying? And then also there's a lot of questions about safety. It being a new propulsion system, a new fuel, if you will. Community engagement and community acceptance is very important. And then finally, under landing and parking, traffic patterns. Are they taxiing on the ground? Are they not taxiing on the ground? Proximities to terminals and taxiways. The importance of an obstacle-free ramp and passenger flow from land side to the air side. So that's what we're going to be going into. So, and again, forgive the formatting, something moved around in the upload, I think. So, so when I talk about near term, I think it's important to understand that in the early days, there's obviously fewer airplanes. It's a new technology that's just being introduced, and the cost is going to be higher. As we move forward into the future, the goal is that costs come down to where it's accessible to everyone. As we move through this, I think these are the topics that we're going to be addressing in the various terms as we move along this continuum. Obviously, at the beginning, we have proof of concept. We still don't have a certified eVTOL aircraft today. I'm a firm believer that operations will start at airports, and in talking to the manufacturers, they seem to agree. I think the reason for that is pretty straightforward. Airports exist to serve general aviation aircraft. These will be certified as general aviation aircraft, and the airports are already set up to accommodate aircraft. So I think it makes sense that they start at airports. Also, at the airport, I'm a firm believer, and again, I'm hearing this from the OEMs as well, that they will start at the private terminals, the FBOs. These are mostly they're private companies or public companies. They're non-governmental is what I'm trying to say. They can move a little quicker in getting the infrastructure put in. They also have commitments and lease obligations to improve their property over the course of their lease. And knowing that this new generation of aircraft is coming, it's a logical next step. Once we move past airports, then we talk about, well, what airports? The OEMs have started to announce launch markets. Southern California, Dallas-Fort Worth, Houston, New York City, and Miami seem to be the ones that several eVTOLs are mentioning on a regular basis. Now that we've gotten to this stage of announcing launch markets, community acceptance is really starting to pick up, and all those topics that we spoke about there. And that's going to be very key in the start of operations. There's more questions than answers today, and the OEMs, along with partners like us operating the private terminals, need to have regular, frequent conversation with our local communities, with our elected officials, with the airports about what this is going to look like in the near term. And then we move into midterm and long term. Then we start to talk about off-airport, dedicated vertiports, landing areas built specifically for these aircraft off-airport, secondary markets, and then we move into my definition of long term is where you now have vertiports or landing and takeoff areas co-located in transportation hubs. This could be co-located with a commercial airline terminal, rail, or other modes of transportation. But that integration is going to take more time because it's more complicated and less land available. So let's talk charging infrastructure for a moment. On the power requirements, what we're putting in at John Wayne Airport is we're going to put in double what you see here. So what we have here, this 483 phase, the 600 kVA, 1000 amp main breaker, is in conversations with many manufacturers, they've said this is what we need to charge one aircraft at a very high rate. And at this rate, they can take one of the early production eVTOLs that are coming to market. It'll take about 15 minutes where they will then take off, fly 30 miles, land, charge for 15 minutes, 30 miles. They can fly farther than 30, but they see that as their optimal stage length. When it comes to funding, we're funding this at John Wayne. We're a privately owned company. There are currently, and if you know of any, please let me know. I have not been able to find any grants, any incentives, or any public funding whatsoever to help with the installation of the charging infrastructure. None. It's new. It hasn't been contemplated yet. There's still a tremendous focus on electrifying buses and things along those lines. They haven't gotten to this yet. However, Lacy Aviation, in our sustainability program that we established in 2019, we did it for 3 reasons. 1, we want to reduce our emissions and our impact. We want to provide solutions for our customers. And 3, we just think it's the right thing to do. This falls under solutions for our customers. We are an FBO. We sell fuel today and other ground handling services. Electricity is just the new fuel that we're going to be selling. And if we don't start planning now with our local utility providers, in permitting, with our airports, these airplanes will be certified and they can't fly anywhere, which I think we all want to avoid. But funding is a real challenge to scale, given the costs involved in bringing this power onto the property. In Orange County, we're looking at about $800,000 to bring in 2 charging pads. So it's significant. And keep in mind, that may not sound like a lot in airport infrastructure, but remember, I'm putting this in and there's no certified airplanes to actually use it where I can make money back to pay for it. So, but we want to support the industry, we want to be prepared, we want to encourage the industry's growth, and we just see this as an investment in the industry's future. Finally, fixed versus mobile. Currently, everyone is pursuing charging stations, right? I have to run the power to a specific location somewhere on the ramp, and then I bring the plane to the charging station. It would be wonderful, and there are some companies I've heard starting to develop this, is think of a fuel truck, but instead of carrying liquid fuel, they're carrying batteries. From an operation standpoint, it allows much more versatility on the ramp if that comes to fruition, and we hope that they continue to pursue that. Community engagement, again, near term. Concerns, safety of flight, new propulsion, all right, new fuel systems, training, things along those lines. Noise, there's still a lot of questions about noise. I know Joby and many others have published studies. They're working with NASA. Noise is something that is on everyone's radar, that we're hopeful, but until we see it, until we hear it, we're not quite sure. Airspace and traffic flow, there's a lot of questions on where will they fly? How low will they fly? How frequently will they fly? Will they be able to land in places that helicopters can't? Things along those lines. A lot of those things need to be addressed during the normal community engagement conversations. Vertiport placement, when you start to go off airport, and this kind of gets into our midterm topic, but when you start to put landing and takeoff areas in neighborhoods, in cities and communities that have never had that before, that there's going to be more questions than answers that need to be addressed, and a lot of studies there. And then just proof of concept, right? Again, it's new. Am I comfortable with this? Do I feel comfortable in the aircraft as a passenger? And then when we move on to education, I think the first thing we all need to do more of, and we've heard it a lot at this conference, is listen. Ask questions and listen. It's important to gain understanding in talking with our communities and talking with our airports, elected officials. What are their concerns? I've listed some, I know there's more. Share relevant information. Don't hold back. Let's share that information, and through discussion, we'll have greater understanding and acceptance. Dispel untruths, and then at the end of the day, until these aircraft arrive, I think that's going to be the proof, is when they start flying. Okay, landing and parking. So this is a diagram of the new FBO that we're getting ready to start construction on at John Wayne Airport. At the bottom of the screen, you see the taxiway. The orange building is our passenger terminal. The yellow area, you gotta come see it when it's done. It's gonna be our outdoor patio with a big 20-foot glass wall overlooking the ramp. Because we're in Southern California, it's sunny all the time, right? And then the blue are our hangars. And this is just a segment of our overall development. But this is the segment that I feel relevant to our conversation here today, talking about eVTOL placement. So, you see here in the bottom, 2 boxes that are 60 feet wide by 60 by 50 feet. And again, working with our eVTOL OEM partners, this is the area where the aircraft would park while they're charging. Okay, the 2 pink boxes, those are 10 feet by 20 feet. Those are charging units. And at this point, we're hopeful that those charging units come to us on wheels. Think like a ground power unit that you pull up to the aircraft and then start the diesel engine and plug it in. We're hoping for that, simply because we want to be able to move them if we need to move ground operations. The pink line is indicative of the taxi lane. So you may be saying, why are you showing all this? Okay, as we started to think through where these aircraft are going to go, we had to think differently. These are intended to be high frequency operations. Currently, when a plane lands in FBO, it could be there for days, weeks. These are intended to come and go every 15 minutes. So they needed to be in a location with easy access to the taxiway. They also needed to be in a location in close proximity to the passenger terminal, because we don't want passengers every 15 minutes walking across. If I zoomed out, we have a ramp of over 5 acres. We don't want them walking through airplanes and propellers to get back and forth. But we also didn't want it too close to the passenger terminal, because there's a lot of spinning blades, and when people walk out and see spinning blades, that's not a comfortable sight. So, and then we also needed it in a spot where, knowing that initially it's probably going to be a fixed charging station and not mobile, where can we put these above ground units that are affixed to the ground that don't move, that wouldn't interrupt the rest of our operations? Because we still have to service all of general aviation, flight schools, pistons, corporate jets, helicopters, everything else. So we kind of settled on this after a lot of conversation with our OEM partners. And as you can see, they'll probably taxi in and make a turn, or they can come directly off the taxiway and then exit. And then you can see the proximity to the FBO. And we believe this kind of checks all the boxes, until I met with Wisk last week, and they threw me a curveball, because their eVTOL is planned to be autonomous, no pilot, and there's no gear, so it doesn't taxi. And they said, that's not going to work for us. So, but listen, this is why it's important to have these conversations. In the course of a 30-minute conversation, we worked out something that might work for them. And they also went back to the drawing board with the understanding that, hey, listen, the challenge that Lacy is facing in building this at an FBO is going to be the same challenge a lot of FBOs are going to face. So let's work on a solution that's going to work for both the manufacturers and for ground operations at the airport. So with that, look at that. I'm dead ringer on time. This is a photo of our new location at John Wayne Airport. We're hoping to start here in the next 30 to 40 days. We're very close. If you have any questions, I'd love to talk with you. Thank you.
Thank you, Scott. So our next presenter is Matt Friedman. Matt Friedman is the Chief of the Office of Aviation Planning in the Caltrans Aeronautics Program. He is a native of Burlingame, California, and has earned degrees from Macalester College, Biology, Anthropology, the University of North Carolina, Masters in Regional Planning, and Hebrew Union College, MAHL, Rabbinic Ordination, and Honorary Doctor of Divinity. He's going to be talking about AAM, not Divinity, today. As Office Chief, Friedman oversees statewide airport area land use planning that includes providing guidance to airport land use commissions and local agencies. He oversees review and response to local notifications of intent to overrule ALUC determinations. Current projects include revising the California Airport Land Use Planning Handbook and the California Aviation System Plan. He participates in activities related to advanced air mobility, research projects pertaining to assessing locations of potential vertiport sites. With that, welcome Matt, and go ahead, Matt.
Okay, thanks so much. It's a pleasure to be with you remotely. I've enjoyed hearing the previous speakers, and I can see there's some wonderful discussion going on. The slides should be available. I'm going to run through them and then make sure we have enough time for Q&A, which I'm sure will be excellent. Oops. What is that? There we go. So I'm not going to define air mobility, advanced air mobility. You've heard that. But I'd like to share 3 ideas that really frame the way we can discuss this topic. And those are convergence, revolution, and policy/ethics. The convergence element is that we have topics that are coming together that never really touched each other before. For many years, airports were off in their own realm, doing their own thing, flying airplanes. And cities sat in their own realm, doing their own things as well. With the advent of advanced air mobility, we're beginning to see aircraft coming into communities. Now, they're not here yet, as we heard from our last speaker, but the thought is eventually they will. We also have convergence in terms of different topics of trying to find various policies that I'll speak about in a moment to align with each other. So what's the revolution? The revolution is that this all is happening very quickly. And the fun part of it is that we're participating. And I'd like to posit the fact that we've never been in a time that's been as amazing as what we're experiencing now. Perhaps the very early days of aviation when airplanes were brand new, but with the advent of AAM, we're going to see more aircraft of many different sizes doing many different tasks and creating questions and challenges that were unconceivable just a few years ago, such as how do we manage all the airspace with all these aircraft flying around? How do we deal with the impacts of noise within communities and changes in movement patterns? And finally, it's policy and ethics. And as we heard in a discussion in our keynote speaker and also the last speaker, is we need to get a greater sense of cooperation with the participants. And that's kind of where we come into at Caltrans. We have 3 offices in our division of aeronautics. We have the Office of Airports that inspects and monitors over 200 public use airports and over 100 heliports in the state of California yearly. The Office of Technical Services that administers grants and loans. And then lastly is the Office of Planning, which is the office I chair. And we are focused on the land use planning elements. One of the challenges we have is that our documents and our guidance is not keeping up with the technology. And I would not put that as a fault of our work. I would say this is an element of new technology being developed. And I would further say that any technology throughout history that is developed always outpaces the policy and also outpaces ethics. And just think for a moment of any technology that we use, whether it's a computer, a car, a rifle, a light. It can be used for positive elements. It can also cause problems. And again, with aviation, we have ethics and policy coming to bear. So here's a photo of a Joby aircraft, and we've spoken about some of the different manufacturers, Wisk, Joby, Archer, and so forth. And I've seen this aircraft and I've seen it fly, which tells us that it is not just a conjecture of what could be, it is what it is. Joby and Archer currently are undergoing airworthiness certification with the FAA, which means they are coming. I spoke to the California chapter of the American Planning Association at a conference back in September, and I told the planners, I said, folks, you need to be ready for these because the manufacturers and the investors have put a lot of effort into making these come to be, and they're going to want to use them. I'm not going to go through the acronyms of advanced air mobility. The slides will be available, so anything that I present today will be viewable down after our conclusion. So how does airport land use planning happen here in California? We are guided by the Public Utilities Code, and specific the part that's called the State Aeronautics Act. And the State Aeronautics Act says that Caltrans will issue guidance to local communities to conduct airport land use planning, and that we will articulate that set of regulations and processes through the California Airport Land Use Planning Handbook. So essentially see the broader idea and the broader law is being contained in the Aeronautics Act, and then the how to do it in the handbook. And the links are there, and again, they'll be available to you with the slide deck. In California, pretty much every airport, with a very few number of exceptions, is governed by an Airport Land Use Commission. And the Airport Land Use Commission has 2 tasks. The first is to compose an airport land use compatibility plan. And the compatibility plan for the airport outlines safety zones and also noise contours. And how are those safety zones, how were they developed? They were based on NTSB crash data, and those areas that were identified as having clusters of higher risk have greater restrictions on land use. And those areas emanating farther away from the airport or the runway sides has fewer restrictions. And when it comes to noise, we use the 65 CNL that we heard discussed during the first keynote this morning. And the restrictions are specified as to what's permissible and not permissible within that area and what mitigations are required. Now, the handbook was written the last time it was finished was 2011. And that's a few years ago, which meant the actual work was predated 2011. So we're going on 15 years since the handbook was completed, which means it's out of date. I don't think we use anything that's 15 years old as a guidance anymore. The good news is that we're in the midst of updating that document now. We're concluding some research with the team from UC Berkeley who have been looking at more recent NTSB crash data, which includes data that are more accurate in terms of the geolocation of crashes. We anticipate getting those data from Berkeley soon. And if we need to adjust the safety zones, we'll do so. We're also looking at changes in land use policy that will impact how we look at the density and intensity of development. And one of the big ones is the increase in the number of auxiliary dwelling units, or ADUs. And this is where we have a big conflict in California. And some of this was mentioned indirectly in our keynote speech, is the importance of land use and land use planning. The state of California in particular recognizes that housing is not always available to all those who need it. And it's a major challenge in the state of California. And so in that effort, 2 points have come up. One is the elimination in many communities of what is known as single family dwellings. That is, that there will no longer be single family lots, that each lot will be eligible for up to 4 additional units of housing pending adequate space and setback and so forth. That's one element. The other is the regional housing allocation requirements, or RHNA. And the RHNA requirements are pushing cities to increase their housing stock. And then we come into a conflict. Where is their land? Oftentimes it is near an airport that hasn't been developed or can be redeveloped. And we're seeing in a number of communities across California where areas that were light industrial near the airport are being redeveloped into mixed use, commercial and medium density residential. An example of that would be along Rollins Road in Burlingame in the southern part of Millbrae, adjacent to SFO up in the Bay Area, where Burlingame is moving to redo some of these, what had been light industrial and put in residential. And this is happening across California. So we see 2 competing goods. One is to minimize exposure to noise and pollution, and the other is to increase the availability of housing and affordability. And sometimes there's a conflict there, which comes down to the point that we heard from Mr. Kirsch, is that land use planning is essential. In California, land use planning is a local effort, which means it's not done at the higher state level, and the local communities very much want to maintain control over that. And again, there's a balance because the state has priorities, and yet at the same time, we want to maintain the autonomy of the local communities. So I've spoken about some of this already. I'm going to skip through this slide. The next phase of responsibilities for the Airport Land Use Commissions beyond developing the Airport Land Use Compatibility Plan is to review development proposals. And they will review a proposal and see if it's consistent with the plan. If it's consistent, then it goes back to the local jurisdiction, and the local jurisdiction will decide whether or not that proposal is appropriate relative to its own zoning ordinances. But then comes a conflict. Sometimes the proposer of a development say, well, we still want to construct this development, in which case the local land use planning jurisdiction, a city or a county here in California, has the option to overrule the land use commission. And they will put forth a proposal to overrule. It must go before a public hearing, and then a majority vote of that body, the council or the board of supervisors. And the record so far has very much favored that these overrules go through with great frequency. The question comes up, is this a good way to proceed? Are we beginning to put in developments or increase the number of developments that really shouldn't be there because it causes other problems? So a little bit about the role of AAM in the transportation system. It's also important when we start to think about AAM is how does it fit in? And most of the manufacturers and most of the discussions about placement of AAM, as mentioned in the last presentation, will be airport to airport. But now we will start to look to airport to community. And how do we wish to do that? where will we place these new facilities? How will they be accessed? And let's see, get that. So we have begun to start to look at the placement of vertiports, and it becomes very much a local land use issue. And again, speaking back to from Mr. Kirsch's presentation, is that land use planning needs to be at the forefront of this. And we in our country have seen in the past where the construction of new infrastructure has brought about unintended and sometimes intended negative consequences. I'm speaking specifically of the interstate system, which greatly revolutionized the movement of goods and people across this country, but also caused a fair amount of disruption within communities where inner cities were divided, and frequently it was communities of color and economically depressed areas that suffered the greatest damage. And that damage remains today as an issue. It is so crucial for us now when we begin to look at the placement of vertiports that we do so in a way that will not cause negative consequences, that these will become opportunities for enhanced transportation, increased access, increased mobility, and not a detriment to segments of the society. To that end, last year, 2 years ago, Caltrans worked with the San Jose State University Mineta Institute to do a vertiport case study. And this study looked at 3 different areas. It looked at the San Jose area as a representative suburban area, San Francisco as an urban area, and Livermore as a rural area. And what was interesting is we used GIS constraint mapping for a number of different factors, including access to transit and socioeconomic data and so forth. And what you see on the right side of the screen are those parcels that were found to meet all the criteria that we set forth. What's interesting about this is that the location with the greatest number of parcels that would be suitable would be in San Francisco, which is a dense urban area. And Livermore was the last, which intuitively would think because it's more rural would have more suitable locations. But again, this gets down to the concept of access, and that AAM should be accessible across the community to all individuals. And that's where the concept of transit accessibility becomes a factor. This study looked at commercial parcels only. It did not look at residential areas and residential parcels. It's a start, it's a beginning study, it's a first attempt to really begin to identify and list those factors that we should consider. And that's really when land use planning happens. And so what do we need to consider? How can we make this choice of vertiport locations a good one? So what are some of the local issues some of the issues for planners? And they're listed here. Obviously, noise is a big issue. Equity is a big issue. Caltrans just yesterday released its equity index, which I have not had a chance to engage with too much because it just came out. But I urge everyone to take a peek at that as a tool for making sure that transportation decisions are made with fairness across the community. So what do we do? How do we make this policy come up to date with legislative guidance that is not up to where we are, and a policy guidance that's not up to date? And that's the challenge we're facing. And that's what we're working on right now with our revision of the handbook and with some of the discussions we're having. And it's an exciting time to be in this field. And we look forward to our ongoing participation within that. As far as background information, I'd like to share some resources that are available. There's guidance from the FAA, including their Engineering Brief 105 about vertiport design. NASA has put out some excellent documents, including a playbook regarding vertiports that came out back in May of last year. And there are other organizations such as the Community Air Mobility Initiative, or CAMI, that provides training as well as materials for community organizations, municipalities, and other people engaged in decision making. The American Planning Association is about to release a document regarding vertiport placement and design and other issues related to vertiports. And we're waiting on that to come out. As we speak, the good news is that there is a tremendously high level of activity occurring across the country regarding this topic, and a lot of good conversation, good discussion. We're still in the early nascent stages, but I imagine for the next couple of years, we're going to make tremendous progress. So again, these slides have the links, and I recommend these sources as potential guidance. I'm going to stop there so we can go on with some Q&A, because no doubt the questions from our participants in the hall will spur some interesting discussion.
Thank you, Matt. Appreciate it. And now we're going to enter the Q&A session. And actually, yeah, I'm going to ask the first question, and then Alex will ask the next question. We're kind of going to go back and forth. There's a lot of questions, so I'm glad that people found this informative. So the first question to Scott is, do these infrastructure changes you're installing to support electric aircraft require an update to the airport's ALP, the Airport Layout Plan?
It's been a popular question lately. Our development, where we're demolishing current buildings and building new buildings, obviously that was part of the airport layout plan that was approved. The infrastructure, the power that we're putting in the ground from the street out to the where the chargers will be, is considered part of that development and is part of approved in that airport layout plan. The question mark, and we're still working with the OEMs on this, is the charging units. If they are fixed, they will likely need to be part of the airport layout plan, where if they are mobile, they won't. But we don't have a definitive answer on that yet. There might even be somebody in the room that has an answer on that. I don't have it.
Thanks, Scott.
Great answer. Next question is for Andy. Andy, have you considered variations of N above to address some of the weaknesses you identified, such as more than one LMAX level or penalties for high cadence?
Well, there's a couple of questions in there. So I think that there are a number of ways that those could be addressed. I think that one could imagine a K equals 10 metric, like an equal energy metric with a cadence penalty. One can imagine a reformulated number above metric. One of the problems that you wind up with that, which is actually the same problem that was mentioned in the keynote address, which is there's the difference between the metric and the threshold. The number above has this extra threshold to it, right? So not only do you have a threshold in the community, which is like, when is number above a significant impact on the house, for instance, but then you also have a threshold built into the metric itself, which becomes one of its weakness, as in the case of the custom unit. So there are multiple ways that you can address any of these things. And this is kind of the subject of ongoing research. We are not making a particular policy recommendation to anybody. Again, this is kind of a new concept, this idea that people can be annoyed, different people can be annoyed differently. It's so obvious when you say it, but in terms of the technical basis for it and technical defense for it in the literature, it's actually not quite widely encountered. So I hope I answered the question.
Great. Thanks, Andy. I'm going to combine two here, and this is for Matt. It's kind of a two-part. So is there a city or cities in California that are more ahead on addressing advanced air mobility land use and what they're considering? And as part of that question, since Caltrans does airport inspections or is associated with airport inspections, how will there be potential funding increases to Caltrans with all the potential thousands of landing and safety sites with these vertiports might come in? So which cities in California, and then how will Caltrans address the entire state in terms of funding?
As far as cities that are engaged, LA was is probably the leading city, though others are engaging, is not quite to the surface yet. So there's the Urban Mobility Lab worked with the city of Los Angeles, Clint Harper and Gabriela Juarez put out a publication. I think I'm trying to recall the name, probably 3 years ago now. There's also discussion what's going to be the element of AAM at the Olympics in 2028. Other cities have showed some interest, but it's all very nascent. Nothing specific that's firm. Now, the other question was in terms of inspections of vertiports. Is that what you're asking?
Say that again?
Well, the second part of your question, the role of Caltrans, as it is
Yeah,
now.
how will Caltrans address all the potential new hundreds to thousands of landing sites in terms of funding for Caltrans to support that?
As far as funding of the sites, Caltrans has not addressed it at all yet. As far as inspections and oversight, if you were to check in the airport land use planning handbook, there are heliports already that are required to have airport land use compatibility plans. And again, here's an example of policy and law not keeping up with the technology. My own thought is that when vertiports are being placed into communities, not only will there need to be local land use law and zoning adjustment, but also that we'll need to adjust where the state is getting involved and whether or not there will be inspections and so forth. We haven't moved on that yet. It is being investigated and studied. And other states are in similar places. Some, based on the topic, are a bit farther ahead or behind. We're really kind of, in my mind, at this point where we're very much set for it to just spring forth and have a rapid acceleration of the rate of change and the rate of adaptation. But I think the primary question I'm hearing is how much money is the state going to give out? At this point, none yet. But that doesn't mean no.
Great, thanks, Matt. Alex, you got a next one?
Yep, I'll jump to the next one. There's a question about Mosaic and if it will help in certification of eVTOLs. I think the FAA is still looking at how those will be certified, but the direction that is currently being pursued is that they'll be certified under a whole different category of powered lift.
Alex, can you define FAA's Mosaic or what that's referring to, or?
I think it's too bad that Matt is not here because that's something that
Okay.
he'd be more familiar with. But ultimately,
Pretty in the weeds.
it's something that helps with the certification of experimental aircraft and another path for certification essentially.
Okay, great. Sorry.
Yep.
Thank you.
There's a clarification question for Scott. Does $800,000 to install a charge site include bringing power lines from suppliers like DWP or Edison?
So we were fortunate that the power is available at our site without any upstream infrastructure being required of Southern California Edison, in this case, in Orange County. What that is basically from our switchgear, we have to travel about 250 feet out to the charging pads. And so it's the trenching, the cabling, the provisioning for that is how we get to that number. Like I said, we're putting in two. So the PVC that the cables run in are 4-inch, there's 8 4-inch PVC pipes, and then the copper cabling will be running in those. So it's probably a little higher than maybe some other sites that might not have to travel as far, but it gives you an idea of the infrastructure required because, as I mentioned, that was the most suitable place on our property for that. If we put it closer to the buildings, we would run into those other issues that I spoke about in my talk.
Thanks, Scott. Next question for Andy. How does NASA choose their subject groups, and has NASA studied specific groups of people, for example, a study group of people that have already been subjected to airport noise?
The people that we use in our study, in our in-person studies, typically are just members of the local community here in the Hampton Roads region. We have kind of an odd, granted, we have a kind of an odd relationship with airport noise around here because there's a lot of military aircraft. There's every different branch of the service represented here, and they all fly different things at all times of the day. Though laboratory science, there is a kind of like an unknown link between laboratory science and what you do, what you would observe out in the field. And so we're not really trying to say anything about how people feel in Seattle in particular or whatever. But I mean, obviously, when you look at the NES, there's this appreciation for different communities or different, or at least the way I would kind of frame that based upon what we've done in our studies is when you look at individuals, you get an appreciation for the fact that people are running kind of like different programs in their head of how they're adding things up. And when you look at things on a kind of gross view, a zoomed out view, and you look at it in terms of a very gross metric like DNL, like a very highly averaged way. And then you get this idea that, well, these people are just more sensitive than those people. And there can be something very different actually going on underneath, like in people's minds, something very different and very definite. It looks like people are just, oh, these people are just more sensitive than those. And it can be a lot more intricate than that. So on a person by person basis, on a community by community basis. So what we're doing in the results I showed today, we're kind of averaged across our community here. But we have an appreciation that everybody is, people can be quite different.
Thanks, Andy. And to get us back on schedule, Alex is going to ask the last question here. And then if there's lingering questions, you can submit them and then also talk to Scott later. Go ahead, Alex.
Yep. Thank you, Tim. So just one more point on Mosaic. It applies to light sport aircraft, and that's something that is a policy change that the FAA has announced last summer, 2023, and it allows for increase in weight and some other aspects of those aircraft. As the use of light sport aircraft, as we heard from Matt with Sling yesterday, is becoming more and more popular, the FAA is seeing that as an opportunity to expand and make more use out of it. So that's what Mosaic is. The last question is going to be for Matt. It's a really good question. We'll require you to think about a little bit, but is there a city or cities that are more ahead on addressing AAM land use, and what are their attributes?
That's a wonderful question. And I'm going to plead partial ignorance because there may be cities that are working on the topic that we're not aware of. I would say that of the cities in California that we do have knowledge, again, Los Angeles is leading the way, but also I know Long Beach has been engaged with this as well. What was the second part of the question?
So cities that are more ahead on addressing AAM land use, and then for those that you're aware of, so feel free to pick the ones that you know
I would
about.
say probably
What are their
there's
attributes?
also Orlando is working on stuff, Miami outside of California. But I would, within California, say probably Los Angeles, at least in terms of outwardly facing activity, they're probably in the lead.
What are the attributes? What separates them from the rest?
Well, they did the work with Urban Mobility Lab, and they put out a document, which of course I'll remember the name of as soon as I get off the call. And they even looked at some tentative sites within Los Angeles. Right now, Caltrans is assisting California State Transportation Agency, CalSTAR, with a study that was put forth by Senate Bill 800. And it's starting to look at potential routes and some potential locations. Nothing that's shareable yet at the moment because it's all conjecture, but that's done at a high level. That's done at a theoretical level. So as far as actual cities, I'd say Los Angeles and Long Beach are probably leading the way. I know San Jose has had some engagement with it as well. Ramses Madhu, who's one of their senior planners and multimodal planners, have been engaged with the topic. And I'm sure a bunch of cities are saying, like, wait a minute, we're doing stuff. I'm just not aware of it, but I do. And if any other cities are aware or are present today, want to pass on their activities, I'd be more than eager to hear about it.
Okay, great. Thank you, Matt. We appreciate that. And so we're going to wrap up. So thank you, Matt, Andy, Jonathan, Aaron, Alex, Scott, and appreciate it. And so we'll have a break, and we'll be back at 11:10. So thank you, everyone.